Let us review the use of matrices to solve a pair of simultaneous equations. Simultaneous equations involving two variables. In this case, we have x and y. We have 3x plus 2y equals 29. We also have 7x minus 4y equals 7. So, let's go. We first of all rewrite the equations in matrix form. So we have 3, 2, 7, and negative 4. And these multiply x and y to get 29, 7. You see that? So now, remember, if you should multiply out these matrices, you remember the work that we did on multiplying matrices. Row by column, 3 by x plus 2 by y equals 29. So this 3 by x plus 2 y equals 29, right? And then 7 by x plus negative 4 by y equals 7. So it's 7x plus negative 4y, meaning minus 4y equals 7. Alright, so here now, we're going to have xy. So xy would be equal to 3, 2, 7, negative 4. The inverse of that, 29, 7. Alright? Now, in order to find the inverse, what we did was to have 1 over the determinant of this matrix multiplied by, and then we interchange A and D, change the sign of B and C. Remember that what that was about. So we have x, y equals 1 divided by the determinant. What was the determinant again? Remember, this is in the form A, B, C, D. We interchange A and D and change the sign of B and C. Remember that. So, interchange 3 and negative 4. So, the determinant of the 2 by 2 matrix is no, we don't interchange it. We're finding the determinant. 3 by negative 4 gives negative 12 minus 7 by 2 is 14, because the determinant of this matrix would be AD minus BC, right? So negative 12 minus 14 would be negative 26, and multiply that by, now we do the interchange. Negative 4 comes up here, 3 goes down here, 2 up here, no, 7, no, 2 remains. We just change the sign. So those in the leading diagonal, we interchange them, 3 and negative 4. Those in the non-leading diagonal, we don't interchange them, we change the signs. So when 2 becomes negative 2, 7 becomes negative 7. Alright. And that will multiply 29, 7. Alright. Now, here, what we can do is just multiply these two matrices. So we have the 1 over negative 26 remaining in place. We have row by column, negative 4 by 29, negative 2 by 7. So negative 4 by 29 is what? Going to be 29 by 4, 4 9 is 36, Bring 6, carry 3, 4 2s, 8, 9, 10, 11, 116. 116 plus negative 2 by 7 will be 14, negative 14. Then negative 7 by 29. 29 by 7, 7 9, 63. Bring down the 3, carry 6. 7 2 is 14, 14 and 6, 20. So this is negative 203 plus 3 7 21. Alright. So what do we get here? It's negative 1 over 26 by this new matrix. 116 minus 14 is 6 minus 4 is 2. 1 minus 1 is 0. Alright, so it's 102 up here. Right? Oh. This is a negative 116 now. It's a negative 116. I didn't realize before. Alright, so it's a negative 116 there. Remember, it was negative 4 by 29. Right? That gave you a negative 116 plus negative 2 by 7. So we have negative 116 minus 14 there. Let me write the negative 1 over 26. And that multiplies 6 and 4. I'm adding these. Negative 116 minus 14 would be 6 and 4, 10. Carry 1. 1 and 1, 2 and 1, 3. So that's negative 130. Alright? And then we had, let me make sure to put the minus sign here early before I forget. So we had here negative 7 by 29 plus 7, 3 by 7. So this is negative 203 plus 21. Negative 203 plus 21. What is that? Let's just work it out over here. Negative 203 plus 21. Alright, this would be the same as 203 minus 21. And then you change the sign. Right? Because it's going to be a negative. It's going to be a negative. So if you say 203 minus 21, you're going to have 3 minus 1 is 2. 0 minus 2 you can't. This is 8. So this is going to be negative 182. Alright? It's negative 182. So now, here, xy would be what? We're getting down to the final step. The matrix x, y would be equal to, this would be negative 130 over 26 over negative 26, and then negative 182 over negative 26. Let's just use a calculator for this. Alright, so 130 over 26 is what? 130 over 26 equals 5. That's 5. And then 182 divided by 26 equals 7. So we have 5 and 7. X equal. X equals 5, y equals 7. So x would be equal to 5, y would be equal to 7, right? So let's go back up here and write it down. So what we're saying is that x is 5 and y is 7. Alright, you can test this to see if it's right. 3 times 5 is 15, plus 2 7s 14, 15 and 14 is what? 4 and 5, 9, 1 and 1, 2, right? It works with equation 1. Let's try equation 2. 7 by 5 is 35. Minus 4 by 7, since y is 7, 4, 7 is 28. Do they subtract to get 7? Let's see. 8, 15 minus 8 is what? Alright? It's 7. And then 2 minus 2 is 0. So it's 0, 7, which is 7. Alright, so it works. Now, this is just a review of 2 by 2 matrices. What we're going to be doing a bit later is to find the determinants of 3 by 3 matrices, right? And we're going to be solving 3 by 3 matrices, or solving simultaneous equations involving 3 variables using 3 by 3 matrices. Now, if you look at what we did here in finding the determinant of the 3 by 3 of the 2 by 2 matrices, and then what we did was AD minus BC. We said this times this minus this times this. We're going to be applying that later on when we come to finding the determinants of 3 by 3 matrices, and then using those to solve equations involving 3 variables instead of 2 variables. So we'll do that in later videos, so I'll see you then.